Good day, great learners. Welcome to our mathematics lesson. I am Skulile Ngube, and this lesson is proudly brought to you by the Gauteng Department of Education. Right, great, we are going to do our lesson on the properties of quadrilaterals, and we are going to concentrate on the sides, angles, and diagonals of the quadrilaterals. Okay, right. So grade 10s, we are going to be writing a lot today. There's going to be a lot of notes that you're going to write. So I want you to be ready for that. And also you have your pencils. We are going to be drawing these quadrilaterals. And then after that, we'll discuss the properties of these quadrilaterals. And I want you to write those notes. Okay, so today is a lot of work, like in terms of writing notes. I think I've only 3 activities that I'm going to give you. The rest of the time we'll be discussing and writing notes. Okay, right. Let's start our lesson, grade 10s. At the end of the lesson, you should be able to investigate properties of quadrilaterals. We're going to be investigating properties of quadrilaterals. And then in grade 8 and 9, we did the geometry of lines and then the geometry of triangles. Okay, right. A quadrilateral is a closed four-sided shape. A closed four-sided shape whose interior angles add up to 360 degrees. Remember, triangle, the interior angle is add up to what? 180 degrees. But a four-sided shape, the interior angles will add up to 360 degrees. Please don't write notes now. If you want to write, you can write, but just short notes. But if it's time for you to write, I'll tell you, okay? But for now, I just want you to listen. Right, and then state if the following statements are true or false. We have how many of them? 6 of them. 30 seconds for each, so you need 3 minutes. Let's try to answer these 6 in 3 minutes. Let's try. Right, welcome back, grade 10. I really hope you managed to get the answers correct, isn't it? Okay. A rectangle is a parallelogram. Is it a parallelogram? Yes, it is a parallelogram. We're going to discuss about that. Okay, let me just give you answers for now, and then we'll discuss. You'll see that why I'm saying a rectangle is a parallelogram. A trapezium is two pairs of adjacent sides equal. A trapezium. You remember what a trapezium is? Don't worry if you can't remember that. I'll show you what a trapezium is. No, this is false. It's actually the kite where the adjacent sides are equal. It is the kite, not the trapezium. Okay? Right, a parallelogram is two pairs of adjacent sides parallel. A parallelogram is two pairs of adjacent sides parallel. You may be tempted to say true here, but it's actually false. It's actually false. Okay, adjacent side means what? Adjacent side, they share a common vertex. Right, let's say we have a parallelogram like this. You see that? Let's call it AB. Oh, how did I name my don't worry about the naming there. AB, let's call this one C. So you see AC and AB, they are adjacent to each other. They have a common vertex, a corner there, vertex. Right. So adjacent sides of a parallelogram are not parallel, but the sides that are parallel are the opposite sides. If we had said opposite, then it was going to be true. Now it's false because we said adjacent. A square may be defined as a rhombus. Can we define a square as a rhombus? It's true. Yes, it's true. So a square can be defined as a rhombus. It can also be defined as a rectangle. And it is a parallelogram. Okay, I'm going to show you that very soon. A rhombus is a parallelogram with equal sides. A rhombus is a parallelogram with equal sides. Yes, a rhombus is a parallelogram with equal sides. Right, and then a kite may be defined as a parallelogram. No, a kite is not a parallelogram. So which shapes, which quadrilaterals are parallelograms? You see, we will talk of the rectangle, the rhombus, and what? The square. They are parallelograms. And then the kite and the trapezium are not parallelograms. As you should have marked your work there. Right. I want us to discuss what I've just said. Right, a parallelogram. This shape here is a parallelogram. Please don't write anything now. Let me just highlight. We're going to talk about this, all this shape in what? In detail. That's when you're going to be drawing the shapes and writing the notes. Now, I just want you to what? To listen. Let me give you a highlight about these quadrilaterals. Right. A parallelogram is two pairs of opposite sides parallel. Two pairs of opposite sides parallel. Parallelogram. So this side is parallel to this side. You can see the arrows there. They show us that the lines are parallel, and then this side is equal to, sorry, is parallel. They are also equal, yes. Okay, but let's use parallel for now. Right, see that? So the two pairs of opposite sides are parallel for a parallelogram. And then under parallelograms, we have a rectangle. And you can see that a rectangle now has two pairs of opposite sides that are parallel. So it is a parallelogram. So now, what makes it special now? Why is it called a rectangle? It is called a rectangle because the interior angles, each interior angle is 90 degrees. So it is a parallelogram with interior angles of 90 degrees. That's a rectangle, which is a parallelogram. Okay, so the interior angles are each 90 degrees. That's a rectangle. And then we have a rhombus. Is rhombus a parallelogram? Yes, it is. But now, what makes it special? All the sides are equal. So it is a parallelogram with equal sides. And then the other properties, there are a lot of properties that we're going to look at. Remember, we said we're going to talk about the sides, the angles, and the diagonals. We're going to look at those. Now I just want you to listen. And then still under rectangle, we have the square. A square is a rectangle. Why? Because the interior angles, each interior angle is 90 degrees. So it is a rectangle, which is also a parallelogram. Okay, so now a rectangle with equal sides, and also a square can be defined as a rhombus because it is a parallelogram with equal sides. You see that? So you see that when you talk about the parallelogram, the rectangle, the square, the rhombus, there's a lot of common properties. Like opposite sides are equal, opposite sides are parallel. You see that? There are a lot of common properties because they are all parallelograms. Okay? Just listen for now, maybe 1 more minute, then we start our discussions and writing of notes. Right, and then we have these two, the trapezium and the kite. They are not parallelograms. These ones, we have a trapezium. Trapezium, what do you know about a trapezium? A trapezium, we have only one pair of opposite sides parallel. Remember, parallelogram is two pairs that are parallel. So trapezium is only one pair, which is one pair of opposite sides that is parallel. And then kite, you know the shape of the kite, okay? The kite, we have two pairs of adjacent sides equal, not parallel, adjacent sides. Like this side and this side, these two sides, they are adjacent. They are sharing a vertex there. See that? They are next to each other. Adjacent means next to each other. They are equal. And then this side and this side also are equal. So you have two pairs of adjacent sides equal. Okay? Right. And then let's talk about the interior angles of quadrilaterals before we look at the properties of parallelograms, trapezium, and kite. The interior angles of a quadrilateral add up to 360 degrees. I mentioned that when we started, right? And then it means angle A plus angle B plus angle C, or they are different sizes. Let me use different notation here. And angle D. If you add these four angles, we get 360 degrees. For any quadrilateral, can be a kite, can be a trapezium, can be parallelogram, can be even irregular polygon, which is four-sided. The interior angles add up to 360 degrees. Okay, so the reason is say sum of angles in quad, meaning sum of angles in quadrilateral. Okay. Then now, using what we just discussed, I want you to calculate the value of x for the quad ABCD. And then after that, show that ABCD is a trapezium. Remember trapezium, one pair of opposite sides are what? One pair of opposite sides are parallel. Right, let me just give you a clue, a hint. I know some of you wanted to try this. Let me just give you a hint. How can we prove that two sides are parallel? How can we prove that two sides are parallel? Remember, we did geometry of straight lines. If alternate angles are equal, then the sides are parallel. If corresponding angles are equal, then the sides are parallel. And if co-interior angles are supplementary, remember co-interior angles, if co-interior angles add up to 180 degrees, then the sides are parallel. So use any of those three to prove B. Hence, prove that ABC is a trapezium. Use any of those. You can use, check if you have alternate angles, check if you have corresponding angles, check if you have co-interior angles. If it's corresponding angles, they must be equal for the sides to be parallel. If it's alternate angles, they must be equal for the sides to be parallel. If it's co-interior angles, they must be supplementary. It means they must add up to 180 degrees for the sides to be parallel. Let's try to do this in 5 minutes. Then after 5 minutes, we're going to mark our work. Right, welcome back, grade 10s. Did you manage to get your answers? No, it's fine. If you tried, got it right, excellent. Even if you tried and did not get the answer, it's okay. Let's mark our work. We learn from our mistakes. Please don't forget, I forgot to remind you about our WhatsApp line 063 629 3655. Please send us your WhatsApp. If you don't understand something or you want to just give us your input, please do so. 063 629 3655. Let's interact during the lesson. Right, so we're adding all these angles. 8 plus 2, 8x plus 2 plus 4x plus 2 plus 5x minus 2 plus x minus 2. And then it's equal to 360 degrees because it's sum of angles in quad. That's the reason. Remember, statement and reason. And then now, there's a 1 there. The coefficients of each bracket there is 1. So fortunately, 1 does not change the things in the bracket, isn't it? So we're going to have our 8x plus 2 plus 4x plus 2 plus 5x minus 2 plus x minus 2 is equal to 360 degrees. You see that we can have that even after removing the brackets. And then 2 plus 2 is 4 minus 2, that is 2 minus 2, that's 0. So the constants disappear because they give us a 0. And then we remain with the variables there with x, or the terms with x. So it's 8x plus 4x, which is 12x. And then 12x plus 5x, which is 17x. 17x plus 1x, this is 1x. Okay, it's 18x. So it's 18x is equal to 360 degrees. And then how do we find x? We divide both sides by 18. We find that x is equal to 20 degrees. You see that? Okay. And then now we are asked to find the size of each interior angle and then prove that this ABCD is a trapezium. Let's do that part. So angle A is one of, where there's x, you put 20, then get 162 degrees. Angle B, where there's x, you put 20 here, and then get 82 degrees. And then angle C, where there's x here, you put 20, and then you're substituting there, you get 98 degrees. And then angle D, where there's x here, you put 20, we get 18 degrees. So our angles should be like this: 162 for A, 82 for B, 98 for C, and 18 for D. Now, is ABCD a trapezium? Is it a trapezium? Let's check. Now, if you check angle A and angle D, if you add these two angles, we get 180 degrees. And then these two angles are actually co-interior angles. They are supplementary. So it means AB, you see AB? AB is parallel to DC. Even if you use B and C, we can add B and C, still we're going to get 180. And then these are co-interior angles. That means AB is parallel to DC because the co-interior angles are what? Are supplementary. But now, if we add B and A, if we add this angle and this angle, we don't get 180 degrees, meaning that AD and BC are not parallel. So we have only one pair of opposite sides being parallel here. So this is a trapezium. Okay, right. That's what we're supposed to do. Now, are we ready to look at the properties of our quadrilaterals? Parallelogram, rectangle, square, rhombus, kite, trapezium. The 6 of them. That's what we're going to be doing. So that's why I said we're going to be writing a lot today. Right, let's go to the first one. If ABCD is a parallelogram, the following properties hold. We're going to look at the properties of a parallelogram. I'm going to give you 2 minutes to draw this diagram. Please make sure your diagram is big enough because we're going to be adding information to this diagram. And then if it's very small, it's going to be very, very clumsy. So maybe a quarter of your page. Make your diagram very big, maybe a quarter of your page, and then we're going to be adding information. And then let's do that for 2 minutes, draw the diagram for 2 minutes, and then after 2 minutes, we'll start looking at the properties. Let's try. Right, welcome back, greetings. Thank you very much, Lamula Jubilee Secondary School, for your input. Your input is that I'm moving a bit fast, so I'll try to slow down. Thank you very much for that. If now there's something you missed, please do not hesitate to let us know. Okay, we're waiting for those questions. You mustn't miss anything. If there's something that you think, oh, I didn't get that one right, or I didn't get the explanation there, please let us know the exact question, and then we'll try to assist you. Okay. Thank you very much for your input. Right. Now, I really hope that everyone has drawn the diagram. Please, no one will be left behind. Let's try to move together. That I said we are doing 6 shapes. So because of that, I won't be giving you time to write notes. Try to write short notes as I explain. So don't draw different parallelograms. This is the parallelogram that we have, and then all the information that we're going to talk about should be added on that single diagram, okay? You just keep on adding to this diagram as we discuss. Right, we're going to have one diagram for parallelogram, one diagram for each quadrilateral that we're going to discuss. So the first point about a parallelogram is this. Now I'm going to use these vertices. It's not like all parallelograms are A, B, C, D. It can be P, Q, R, S, something like that. But now we're using this. So the first point, right, we're going to talk about the sides. AD is parallel to BC. Please write that as I explain. And how do we see that? How do we show that on the diagram? Put the arrows. Do you see the arrows I've added here? Along AD and along BC. It shows that AD is parallel to BC. Okay? Write that. AD is parallel to BC. And AB is parallel to DC. AB is parallel to DC. Please add the arrows. Do you see I've added 2 arrows there? Okay, don't add my ticks, just the arrows only. AB is parallel to DC. You write this and add the information on the diagram. Let's just do that. Okay, right. So we can say that for a parallelogram, the opposite sides are The opposite sides are parallel. Please write that. For a parallelogram, the opposite sides are parallel. Like AD is parallel to BC and AB is parallel to DC. Okay? Right, that's the first property for a parallelogram. Please, let's do that. Let's make sure we move together. Please let me know if I'm moving fast. But I want you to try to multitask today. As I speak, you're also writing, just adding information on the diagram. Right, let's move on to the next property. The opposite sides are parallel. And then we're still adding on the same diagram. Don't draw another one. Just keep on adding the properties. Right, AD is equal to BC. Do you see what I've added on the diagram? Do you see the lines? Do you see those lines? AD is parallel to BC. Please write this and add the lines to the diagram. And then AB, did you say parallel or equal? Okay, it should be equal. Ne? AD is equal to BC, equal in length. AD is equal to BC and AB is equal to DC. Do you see also I've added these lines? You see that? Please add those lines. AB is equal to DC. Okay? Right. And then what can we conclude? We can say that the opposite sides of a parallelogram are equal. The opposite sides are equal in length. Just opposite sides equal is fine. Opposite sides equal. Okay? Let's move on to the next property. Right, try to write as I explain. Let's move on to the next one. Right, the lines, opposite sides are parallel, opposite sides are equal. And then AE, or before we talk about that, right, what we call these lines BD and AC, what do we call these lines? What are they called? The lines that I have highlighted in right there, what do we call them? They are called diagonals. Diagonals. Okay. Now we want to look at the properties of the diagonals of the parallelogram. What can you say about the diagonals of the parallelogram? Right. So AE, you see AE? AE, E is at the center there. AE is equal to EC. I've indicated that with these three lines there. AE is equal to EC. Please write that. AE is equal to EC. What about BE and ED? What do you think? BE, check BE. BE and ED, they are also equal. BE and ED are equal. See, I've indicated with these lines here. You see that? BE and ED are equal. We're adding the information in the same diagram. That's why I said your diagram must be big enough. Right. And then now, what can you say about this? The diagonals bisect each other. Okay, the diagonals bisect each other. Let me just give you 1 minute so that if you are behind, you can catch up. Right, let's try to do that for 1 minute. Right, welcome back, grade 10s. What do I mean by saying diagonals bisect each other? The diagonals cut each other into two equal parts. Look at diagonal AC. What does it do to BD? AC divides BD into two equal parts. And BD divides AC into two equal parts. So the diagonals cut each other into two equal parts. That's why you say the diagonals bisect. The word bisect means divide into two equal parts. Okay? Right. Please take note of that. And then we have, please write the angles, like here, angle 1, like just write the angles like I've written here. There's angle A1, there's 1 there, angle A2, let's do that. Angle A1, angle A2, just write 1 and 2. Angle B1, angle B2. By the time I finish, also it should be finished. Angle B1 and angle B2. C1 here and C2. And then D1 here and D2. Okay, please just add that information. Right. We're saying angle D1 is equal to angle B2. We can see that. Angle D1, which is this angle, and then angle B2, which is this angle. Why are they equal? If you check, these angles are alternate angles. AD is parallel to BC. These are alternate angles. What are the other alternate angles? You can see angle D2 and angle B1, the green ones. Angle D2 and angle B1, they are alternate angles because AB and DC are parallel. Angle D2 is equal to angle B1. We still have two more pairs. We have angle C1 and angle A2. They are alternate angles. The dark green ones, these ones, they are alternate angles again. AB is parallel to DC. Right, angle C1 is equal to angle A2. And then the last pair, angle A1 is equal to angle C2. The blue ones, these ones, okay? So you see that they are alternate angles, right? They are alternate angles. So we can talk of alternate angles in a parallelogram because we're talking about, we have what? We have parallel line. Okay? Right, I said you must write as I explained. So let's move on. Let's move on. Right. And then what can you say about the opposite angles? Angle A, the whole angle A and the whole angle C. Angle A is equal to angle C. Write that. You can even highlight your angles on the diagram. And then what about angle B and angle D? Angle B is equal to angle D. And then what do we say? Opposite angles are equal. For a parallelogram, opposite angles are equal. Please take note of that. Opposite angles are equal. Today we're going to be writing a lot. Okay? We're writing a lot today. A lot of notes as we discussed. But please, if you have any questions, please let me know. Right, now we're done with the parallelogram. We're going to the next one, which is a rhombus. Some of the properties of rhombus are just the same as the properties of the parallelogram because a rhombus is a parallelogram, okay? Right, so let's start with the first one. What can you say about the opposite sides of a rhombus? The opposite sides are parallel. The opposite sides are equal. Actually, for a rhombus, all the sides are equal. All the sides are equal. So AD, oh, sorry, grade 10, sorry. We need time to draw the diagram. Almost forgot. Right, let's have 2 minutes. Let's draw our rhombus for 2 minutes. Please make it big enough so that we can add more information. 2 minutes. Right, welcome back, greetings. Right, now the properties of a rhombus. AD is parallel to BC. You see that I've indicated with these arrows here. AD is parallel to BC. Please add the information on the diagram. Write this and add the information on the diagram. And then also AB is parallel to DC. You see, I've added the arrows there to show that AB is parallel to DC. Please write this and also add the arrows on the diagram. Okay, so for a rhombus, the opposite sides are parallel, just like any other parallelogram. The opposite sides are parallel. Okay, write that. Or can just write like this, shorthand, op sides parallel, just like that. Op sides parallel. You don't need to write a lot of things. Right, and then we go to the side, this length of the sides. All the sides, AD is equal to BC is equal to AB is equal to DC. See that I've used the lines here to show that the sides are equal in length. The sides are equal in length. All these four sides are equal in length. So please write that. All sides equal. Just that. Sides equal. Done. Sides equal. Okay. Please indicate that on the diagram. Make sure all the lines are there on the diagram to show that all the four sides are equal. And then what else? The diagonals. We know what diagonals is now. We discussed that with the other parallelogram. AE is equal to AC. Sorry, AE is equal to EC. You can see that. And then BE is equal to ED. I've indicated these two to show that they are equal. And then I've indicated these two to show that they are equal. So BE is equal to ED. So what can you say about the diagonals? Do they bisect each other? Yes, the diagonals bisect each other. Just like in the previous parallelogram, the diagonals bisect each other. Okay, please write that information. The diagonals bisect each other. Okay, that's the rhombus. And then what else? The opposite angles. What can you say about opposite angles? Angle A is equal to angle C. And then angle B is equal to angle D. You see that? So we can say that opposite angles equal. Just op angles equal. It's enough. Okay, op angles equal. Opposite angles equal. That's for the rhombus, just like in any other parallelogram. Okay. Right, let's name our angles. A1, put 1 there. A2, put 2 there. B1, put 1 there. B2, put 2 there. C1, put 1 there. C2, put 2 there. Then D1, put 1 there. And then D2, put 2 there. Okay, just name those angles. Right. And then what can you say about these angles? D1 is equal to D2. And B1 is equal to B2. Let me show you. I say D1, this is D1, it is equal to D2. So those two angles are equal. Ne? So what does the diagonal do to the whole angle D? It cuts it into two equal parts. And then I said that, which way do we use for that? It bisects. So the diagonal bisects the corner angle, divides it into two equal parts. D1 and D2 are equal. And then B1 also is equal to D1 and D2. And then B2 is equal to B1 is equal to D2 is equal to D1. Okay, right. So those four angles are equal. And then if we come again to this blue one, the blue angles, we can see that A1 is equal to A2. Again, the diagonal will bisect the corner angle. You see that? So A1 is equal to A2, and then C1 is equal to C2. Right. What can you say? We say the diagonals bisect corner angles. Right. Let me give you just 1 minute to write your notes. 1 minute. Right. Welcome back, returns. So we have said that let's name these angles. E1 is right on the diagram. E1, E2, E3, E4. Right, those 1, 2, 3, 4 around E there. Right. So E1, E2, E3, and E4, all these four angles, they are equal to 90 degrees. So let me just highlight E1 only. So what can you say about these diagonals? We say these diagonals bisect each other, but for a rhombus, very, very important property, to say this parallelogram is a rhombus. How do you see that? If the diagonals bisect each other at 90 degrees, then that parallelogram is a rhombus. Diagonals bisect each other at 90 degrees. Please write that one down. Diagonals bisect each other at 90 degrees. Okay? So that is a rhombus. Please don't forget that. Add the 90-degree angle there, the corner there, the square there for the 90-degree angle, and write diagonals bisect each other at 90 degrees. Very important. Right, so AC, the diagonal AC is perpendicular. This means perpendicular. This symbol is for perpendicular. Okay, the diagonal AC is perpendicular to BD. Please write that. Okay, right, rectangle. Let me give you 1 minute. We'll have very few minutes. 1 minute to draw the diagram, and then after that, we'll discuss the properties. 1 minute to draw the diagram. Okay, let's try to do that. Right, welcome back. Grade 10s. I really hope you managed to write. Now, I'm trying to make sure that we can use this time, the 8 minutes, effectively. So a rectangle is a parallelogram. Ne? So I want you to write all the properties of parallelogram. Just write this. All properties of parallelogram. we use PAM. In short, for parallelogram, we use PAM. Or some books may see this for parallelogram, okay? Right, all properties of PAM for parallelogram, except, and then we just write the ones that we did not write before. Okay, I'll show you which ones. Right. So I'll just quickly go through all the properties and then I'll tell you, write this one because we didn't write about it when you're talking about the parallelogram. Okay. Right. All the properties of parallelogram except, right, let's discuss. Right. We said all the opposite sides are parallel. So we talked about this when we talked about the parallelogram. So it is covered by this point. Okay. Right. So just indicate using arrows there. The opposite sides are parallel. Use the arrows on the diagram. I hope this instruction is clear, will not confuse you. And then also we said the opposite sides are what? Are equal. We talked about that, isn't it? It's covered by our statement, all the properties of parallelogram. Okay, I've indicated there, show that the opposite sides are equal on the diagram. And then now AE is equal to EC is equal to BE is equal to ED. This one, you have to write it. So now the diagonals are equal. Write this one down. We didn't write about this. The diagonals for any other parallelogram, they are not equal. But for a rectangle, the diagonals are equal and they bisect each other. Please write this one down. The diagonals are equal and bisect each other. For other parallelograms, the diagonals bisect each other, but they are not equal. For a rectangle, the diagonals are equal and bisect each other. Write that one down. The diagonals are equal and bisect each other. Okay? And then let's name our angles A1, A2, B1, B2, C1, C2, D1, D2. Let's do that. Okay, what can you say about these angles? D1 is equal to B2, and then D2 is equal to B1, C1 is equal to A2, and then C2 is equal to A1. We have this property with the other parallelogram, so let's leave it. Okay, we said alternate angles. Do you remember that? You check your notes, it is there under parallelograms. Okay, so let's leave this one is covered by parallelograms. Okay, right. And then now this one is another special property for a rectangle. The interior angles, each interior angle is equal to 90 degrees. Please write this one down. For a rectangle, corner angles equal 90 degrees. Just write that one down. Corner angles equal 90 degrees and indicate the 90 degree. Indicate on the diagram. Corner angles equal 90 degrees. Corner angles equal 90 degrees. Okay. And then, right, okay, done with the rectangle. We're done with the rectangle. Same thing here. For a square, okay, 1 minute, draw the square. 1 minute, draw the square. Right, very good. Let's do this. A square is a parallelogram, so it has got the properties of parallelogram. It is a rhombus. It is the properties of a rhombus. It is a rectangle. It is the properties of a rectangle. Okay. So we say all properties of parallelogram except just like we did with what? With the rectangle. Okay. Right. And then opposite sides are parallel. We have that. Remember, for a square, opposite sides are parallel. We have that under parallelogram because a square is also a parallelogram. Okay, you can write your short notes there. And then all the sides are equal, just like the rhombus. Remember rhombus, all the sides are equal. And then you can indicate on your diagram there to show that all the sides are equal. Okay, all the sides are equal. Please write that, all sides equal. And then AE is equal to EC is equal to BE is equal to ED, like a rectangle. Remember rectangle, we said diagonals are equal and bisect each other. So for a square, since it's a rectangle also, the diagonals are equal and bisect each other. Please write that one down. Diagonals equal and bisect each other. Diagonals equal and bisect each other. Try to be fast. Then just like a rectangle, the interior angles, corner angles equal 90 degrees. 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 And just indicate fast. Indicate fast. Right. And then we said, what did you say? We say corner angles are 90 degrees and the diagonals bisect the corner angles. So meaning that these angles, A1, A2, B1, B2, C1, C2, D1, D2, each angle there is going to be 45 degrees. Each angle there is equal to 45 degrees because the diagonals bisect corner angles and the corner angles are 90 degrees. So if you divide 90 into two equal parts, it's 45, 45. What about the diagonals? They bisect each other at what? At what angle? Remember, square is a rhombus. So the diagonals bisect each other at 90 degrees, just like the rhombus. So the E1 is 90 degrees. The diagonals bisect each other at 90 degrees. Very, very important. Right. I just want to quickly go through the trapezium and the kite. Please just listen. You can take your notes later from your books and all those things, but let's just discuss them quickly now. Just listen. Don't write anything because if you write, we'll need another 10 minutes. So we don't have that time. Just listen. I'll go through the properties of those two. Right. Right. A trapezium, we say that AD is parallel to BC. So one pair of opposite sides parallel, not equal, parallel. And then since they are parallel, these angles, like angle A2 and C2, these are alternate angles, they are equal. And then D1 and B2 there, they are alternate angles again, they are equal. That is enough for a trapezium. Okay? And then kite. Please take note of this. Take note of this. Kite. The adjacent sides are equal. Like AB is equal to AD and BC is equal to DC. Adjacent sides are equal. Please don't write notes, just listen, and then you can take your notes later. And then two pairs of adjacent sides are equal. And then we have BE is equal to ED. Take note of this. For a kite, we have two diagonals, BD and AC. The longer diagonal bisects the shorter diagonal. Like AC cuts BD into two equal parts. The diagonals, they do not bisect each other. There's one diagonal which bisects the other diagonal. The longer diagonal bisects the shorter diagonal. That's the kite. So the shorter diagonal is bisected by the longer diagonal. Like BD is cut into half by AC. Those are the two diagonals. Okay? And then the longer diagonal bisects the corner angles. Like angle A and angle C is divided by the longer diagonal into two equal parts. The longer diagonal bisects the corner angles. That's for the kite. And then what else? Angle B is equal to angle D. We only have a single pair of opposite angles equal. Remember, for parallelograms, it's two pairs of opposite angles being equal. But for a kite, a single pair of opposite angles are equal. Like here, angle B and angle D are equal. Right? And then the diagonals intersect. Take note of this. I'm not saying diagonals bisect each other at 90 degrees. They intersect at 90 degrees because they do not bisect each other. Okay? They do not bisect each other. So they intersect at 90 degrees. So these are the properties of the kite. Right, these are the properties of the kite. And then this is the screenshot. We make it our homework. Just the screenshot, if you can take the screenshot. And then, okay. Right, let's take a short break, and then when we come after break, we'll just summarize our lesson.
The road to success is to commit to yourself. In order for you to become who you want to become as a student, you need to commit to reading your books, to studying, to bettering yourself. I know it's not going to be easy. Actually, no one said it's going to be easy. But if you put in the work, the results will show in your life. Tap into your power. Sometimes you will feel like putting away your books, and not reading as much as you're supposed to be. But I want you to commit, because through commitment, there is infinite power.
No, I know this lesson was a bit long. I tried to cover all the quadrilaterals that we wanted to cover. So the speed was a bit fast because of the content that we had to cover in this lesson. I'm very sorry for that, but thank you very much, as KTL Secondary School, for your input again. That was a bit fast, but we'll make sure that in the next lessons, we try to move very, very slow so that we don't leave anyone behind. Thank you very much for participating, grade 10s. We are going to meet in the next lesson. Please engage other content like your textbooks and other things. And you can also visit this video again and then make sure that you understand everything that we discuss. Let's meet next week, grade 10s, and enjoy the rest of your day. Thank you very much.